Alright, so welcome back, guys. In this video we're going to be talking about chapter 3, and the concept of chapter 3 is solving system of linear equations using two algebraic approach. Those are substitution method and elimination method. So we're going to start by discussing those two methods in this video, and then in the next lesson we're going to solve applications using those two methods as well. So mainly word problems in 3.4. Before we get to examples, let's look at what is the big picture of this lesson here. So usually when you're given a system equation, a linear equation, those are two lines. So we have three scenarios for lines that are graphing the same coordinate system. So let's say we have an x and y coordinate system, and then we have the first line given as this graph. So if I was to graph another line on the same coordinate system, x and y, the second line can intersect this one or not, right? So let's look at the scenario where the second line I draw is going to be intersect this first line here. Suppose the second line intersect the first one at this point here. Okay, so well, this is an system of two lines, okay, graphically, and this point here, we call this point here where the two lines intersect, this is called point of intersection. Okay, point of intersection. Okay, when we solve system of linear equation algebraically, we get a point x comma y. The coordinates is x, y coordinate, and that usually represents the point of intersection. So usually this is what the solution, this is what solutions for system equation, linear equation. Okay. So this is one solution case, and usually this one we refer this as consistent. Is a consistent system. And it's independent, meaning both lines are independent of each other. Okay. Now let's look at a second scenario where we have the two graphs. Let's say we have the first line to be this. Okay. And if I was to draw the second line, not intersect the first line, but the second line doesn't really touch the first line at all, or doesn't have a point intersection at all. So the only way I can think of is drawing the second line where the second line is parallel to the first line. Okay, so in this case here, there's no solution for this system, or in other words, this is, doesn't have a no point of intersection. Okay, so if a system of linear equation doesn't have a solution or doesn't have a point intersection, we call this system here, this is called inconsistent. Okay, so that system of linear equation is inconsistent, doesn't have a solution. And the last scenario is if we happen to have the two lines where if I draw the first line like this, and if I was to draw the second line that is not parallel to this given line, and not just intersecting one point, but what if the third line happened to be the same exact line as the first one? Okay, so in this case here, these two lines are intersecting each other infinitely many times. Okay, so if we have this scenario, we say infinitely many solutions, meaning the two lines are intersecting each other infinitely many times, or the two lines are the same line. So if we have the system where the solution is infinite, this is a consistent solution, but it's consistent dependent because one equation is dependent on the other one. Okay, so this is geometrically the big picture of what this chapter is about. The problems we do in this section is mainly we're given a system of linear equation in their equation form, and we have to solve those system equations using the two methods going to be discussed: substitution and elimination. And we have to at least have a visual understanding what is the solution represent in order for us to understand what's going on So we're not going to solve these problems by graphing, because by graphing our scaling might be off and it's hard to tell what is the precise coordinates for the point of intersection. So we have to rely on algebra to solve the system. So let's get to it. Let's get to the first example. Okay, so example 1. Okay, we're going to solve the system. Okay, and here is the system equation. We have 2x minus y equal to 4, and then 3x minus 5y equal to 2. Okay. So let's discuss the first method of solving this algebraically, and that is solve by using substitution method. Okay, it just means, okay, if I want to solve for the point of intersection, I'm going to go ahead and take one of these equations, solve for a variable, and then take that answer, plug it into the other one, and then solve for the other variable. Okay, so I'm going to choose the first equation, and I'm going to solve for x. Okay, so I'm going to say, okay, let's solve for x. You can solve for y as well. Doesn't matter. Okay, let's solve for x. All right, so that means 2x equal to y plus 4. X equal to 1/2 y plus 2. Okay, so that is my x. Okay, so now I'm going to go ahead and take this and then plug it into the other equation. Okay. All right, so my other equation is this. Okay, so it's 3x, but our x now is 1/2 y plus 2. So I'm going to go ahead and write y over 2 plus 2 minus 5y equal to 2. Okay, so now I can solve for y. Distribute the 3, I should get 3 over 2y plus 6 minus 5y equal to 2. So I can combine the y terms and then subtract the 6 to the other side. So if I subtract the 6 to the other side, I'm going to get -4. And then I can turn this -5y over 1y over 1. So I can find common denominator here. So that will give me, let's see, the common denominator is 2. So that would be 3 over 2y minus 10 over 2y equal to -4. And then that will give me -7 over 2y equal to -4. That will give me 8 over 7. 8 over 7 for y. How do I get that one? I would times this by the negative reciprocal. So 2, 7, -2, 7. So that will give me -2, 7. So that will give me 8, 7 for the y. All right, so that gives us the y coordinate for the point intersection. So now what we're going to do is we're going to go ahead and plug it back into one of the equation to solve for x. Okay, so we can plug that back into the one that we saw for x earlier, like this one here. So that will give us x equals, so 1/2 y now becomes 8, 7 plus 2. That will give us 8 over 14 plus 2. And now that becomes, let's see, that becomes 8, 7. Excuse me. That becomes 8, 14 plus 4 over, I'm not doing the math correctly here. So I can change this over 1, so times by 14, so a plus 28 over 14, that gives us 36 over 14, and then that becomes 18 over 7. Okay, so that is my x coordinate. So the solutions for this problem, so usually the substitution method is not recommended because sometimes you run, you run through a bunch of fractions to get the answer. So the answer here is 18 for 18 over 7, and then 8 over 7. Okay. So that was a lot of work. Okay. if we can avoid fraction, we should. So I wouldn't recommend doing this right off the bat. So this is using substitution method. Okay. So what if I don't want to use that method? I want to use another method. So let's go ahead and solve by using elimination method. Sometimes this is called addition method as well. Okay. We are going to use the same system equation, 2x minus y equal to 4. And then the other one is 3x minus 5y equal to 2. Okay. All right, so let's do this. Let's solve this using the elimination method. So what we're going to do is we're going to pick one variable to eliminate. So I'm going to go ahead and choose y to eliminate. What that means is if I was to add these two equations to create a third equation, the y variable should completely get canceled out. So notice that I have negative y and negative 5y. If I was to add these two right now, the y doesn't cancel out. So I need to manipulate where I add them and then the y term cancels out. So if I was to make the first equation and I'm going to times that by negative 5, okay, that will give me negative 10x plus 5y equal to negative 20. And then my second equation, I'll leave it alone. So now if I were to add these two equations, I would get the y term cancel out. So that gave me negative 7x equal negative 18. Therefore, x is 18 over 7. Look how fast we got x coordinate, which is 18 over 7. And look up here. We did a bunch of math, a bunch of fractions to get 18 over 7. That was a lot of hard work. Here, not so much hard work. So the cool thing about elimination is you can keep doing that again. Once you get the x coordinate or the y coordinate, whatever how you start with. So I got my x coordinates. Now I want to have to solve for y coordinate. So we go back to the 2 equation. What we can do is, we say, okay, now I can, eliminate x to get y. Okay, so this is my x. So we got this by eliminating y to get x. So now I want to eliminate x to get y. Okay, so 2x minus y equal to 4. 3x minus 5y equal to 2. Okay, so how am I gonna eliminate x to get y? Okay, so to eliminate x, we got 2x and 3x. So if we would add them right now, they don't cancel each other out. So how do I turn each of these x terms so that way when I add them, they cancel out? We use the LCM of 2 and 3. Okay, so the LCM is going to be 6 for 2 and 3. Okay, so to get 6, I need to times by 3. Okay, and I need to times this by 2. Okay, but remember, we want these guys to cancel out. So one of this has to be a negative 6x. So I'm going to choose the first one to be a negative 6x by including a negative there. Okay, so now if I do this, I get negative 6x there plus 3y equal to negative 12. The second equation becomes 6x minus 10y equal to 4. And then I can add these two equations. The x variable should cancel out. That will give us negative 7y equal to negative 8. Therefore, y is equal to 8 over 7. And there it is. We got x and y. And our solution should be, in order of pair, we have 18 over 7 and 8 over 7. That is our solution. Look how fast we got that solutions. And look up here. We did a bunch of steps and a bunch of math and bypass a bunch of fractions. And here we just got the answer really quick. Okay. All right. So in the next video, we're going to discuss the other type of scenario where you can have this scenario and that scenario. And how can we tell that from the algebra approach?